Welcome back to the lab. In today's experiment we're going to simply look at the production of ethanol using 4 different sugar washes. Our first sugar wash is the white sugar. The second sugar wash is the raw sugar. The third sugar wash is our brown sugar. And the fourth and final sugar wash is molasses. Importantly, with all of the sugar washes except molasses, the carbohydrate total equaled the exact sugar amount. However, with the molasses, you'll notice that the carbohydrate content is 73 grams per 100 and the sugars are 59. And I worked specifically off the sugar level without any appreciation for the fact that the yeast in the brewing process may consider the total carbohydrate count. So that means that I may need to create a fifth solution that considers that as the total sugar content. And of course, in looking at further data around the hydrometer readings, where I've measured both the hydrometer range and the sugar count according to the hydrometer, you'll notice that the white sugar, raw sugar and brown sugar all have very similar readings, yet it shoots up to 240 for the sugar rating around the molasses count. However, all is not lost, because I think what we'll be able to do once we've finished our fermentation is we'll do the ethanol extraction, and I think you'll find that we'll have sufficient sugars still remaining in the molasses solution to run a second fermentation. So let's get started with the experiment. I first started this experiment around the 22nd of December 2020. The issue that I had was that the yeast that I'd bought had died. So what I did is I kept the solutions that I'd prepared, and we can see from left to right the white sugar, the raw sugar, the brown sugar and the molasses solutions. And what I did is I sealed them up and sterilized them in the autoclave, and that allowed me to just leave them as is, totally okay, until we got some new yeast to continue the experiment. These solutions were prepared according to the formulations that you saw at the beginning of the video for each of the sugar wash solutions. In reading through various blog items from brewers who know far more about this topic than me, they discussed that you shouldn't pitch your yeast and test your yeast in a sugar solution which is stronger than the solution that you're going to be pitching your yeast solution into. So what I decided to do was take a small amount of each of the solutions, autoclave it, and then wait for it to reduce to 40 degrees and then pitch my yeast into that. And you'll notice, of course, that the bottles aren't terrific for pouring from, and you end up with a bit of a sticky mess at the end of it. So once I've poured all my solutions into the autoclave jars, I'm going to just stuff in some polyester and then wrap them in tin foil and autoclave them. And I'm also autoclaving the beakers that I'm going to be using to pitch the yeast into, and so everything is very sterile and nice and clean. So here's our final result. Let's get it all into the autoclave, get it all sterile, and let's get on with the experiment. Just while we're waiting for our autoclaving to finish, what I've done is I've measured out the 0.8 grams of yeast that's required for each of the pitchings into the different sugar wash solutions. Our solutions are now out of the autoclave and they're ready to have the yeast pitched in once they cool down a little bit. And you'll see here that I've got each of the samples with each of the sugar types. Now, while I was waiting for the autoclave to finish, I also sterilized using sodium metabisulfite the vents, the thermometer that we're going to use, and most importantly the stirring rod that we'll use when we pitch our yeast into each of our small samples prior to putting them into the sugar wash solutions. So now it's just a matter of waiting for our temperature on the samples to come back to 40, around about 40 to 45 degrees. So let's see where they're at the moment. They're still very warm, and we'll just check in momentarily to see them cooling down. As each of the vials got down to close to 40 degrees, I moved each of the vials into each of the beakers, which had also been sterilised in the autoclave, and we're now getting ready to pitch the yeast into each of these samples. That does two things. It tests that everything's still alive and that the yeast is good, and it also activates the yeast before we put it into the main sugar wash bottle. So as you can see here, they're all getting down to around about 40 degrees. That one's still a bit warm, and we'll just test each one with the digital thermometer a little more accurately before we go ahead and pitch our yeast to make sure that it's optimum. The temperature of our white sugar wash is now where we want it to be, just around about 40 degrees. So we'll go ahead and we'll pitch our yeast in, and we'll give it a good mix up and just get that yeast activated. This sample held on to a little more heat than the others, probably due to the fact that there was more volume. So we'll just give it a bit of a quick stir around, see if we can't get rid of some of that heat. Leave it for a moment or two, give it a bit more of a stir, give the others a bit of a stir, get that yeast activated, and then when we've done that we can sit down and test our yeast, make sure that it's going. We'll set a 15-minute timer and get it activated. I thought it might be interesting to start a 15-minute timer to see the yeast come alive and see what it's actually doing. So this is what it looks like after just a moment or two. Obviously there was a little bit of time in me setting up the timer and moving the samples around. But what we'll do is we'll just head into a quick time lapse and we'll see what happens to the yeast over the next 15 minutes. At the 2-minute mark, I'd sort of figured that the yeast was well and truly alive and it was doing a terrific job. So decided to give them a quick stir, get that yeast all fully incorporated and homogeneous, and then go ahead and pitch these into each of the respective sugar wash solutions and put the vents on and get the fermentation process underway. I thought it might be a good idea to give each of the bottles exterior a wipe with an alcohol swab. So I've gone ahead and done that and made sure that everything is nice and clean, and we can minimize contamination and those sorts of things in our sterile procedures. And once we've done that, we go ahead and pitch the yeast in, and it's welcome to your new home, little yeasts. So go forth and multiply. And having added the yeast, we then simply add the vent. We'll go ahead and give that some level of distilled water to keep the oxygen out and allow the carbon dioxide as part of the fermentation process to exit the environment. So we'll go ahead and add that in and seal our yeast bottle up and just repeat the process. I thought, having done this process, that it might be a good idea to move each of these bottles into the incubator, which I'd set to 37 degrees just to get that yeast well and truly rocking and rolling. And so I did that, and I left it in there for 4 hours to get that yeast well and truly underway, get it fermenting, get it growing alive. And after just 4 hours I pulled it out, and as you can see here, it's really starting to go off. So this is the molasses mixture, and there's a huge amount of activity. It's really producing large amounts of gas and therefore alcohol, consuming all that sugar. And we'll just have to see how it looks in a few days to a week's time. But as you can see, it's producing huge amounts of gas very regularly. It's well and truly fermenting beautifully. So thanks very much for watching this video. If you like my content, please like my channel and subscribe. But that concludes this video for today, and we'll come back shortly and we'll see how the fermentation process ends up. But thanks very much for watching. Have a great day.